Hey, we're on the last type of reaction, double replacements. These reactions start off with two compounds and end with two compounds. So we'll call the first one AX, the second one BY. They react to form two products, AY and BX. In the textbook, they do a nice job of explaining these, and all these reactions produce some type of solid, gas, or water. And in the next unit, we're going to learn how to predict what happens in the reaction. But for right now, we're just making sure we understand the form of a double replacement reaction. So for starters, we're just going to identify the different A, B, X, and Y for the practice problems. So go ahead and turn to page 297. The first one says the two substances at the right react to produce solid silver iodide and aqueous silver nitrate. And the substances are silver iodine and I should say that lithium iodine and silver nitrate. So when you write that out, we have the reactants, lithium iodine, that are aqueous, plus silver nitrate, which is aqueous, and they react to form lithium nitrate, an aqueous solution, and silver iodine, which is a solid. So that's what the book tells you, and to split that up into A, X, B, and Y, you got lithium, iodine, silver, and nitrate, and they're all either +1 or -1. A and B are +1, and X and Y are -1 charges. The second one is number 26, and that has aqueous barium chloride and aqueous potassium carbonate react to produce solid barium carbonate and aqueous potassium chloride. And so you should try, going through that, but here's the answer. It says barium chloride plus potassium carbonate react to form barium carbonate and potassium chloride. And when you write up the skeleton, you have to have 2 chlorines for each barium and 2 potassium for each carbonate because they don't have the same magnitude on their charge. Number 27 refers to oxalate, which is a polyatomic ion. And in the textbook, you can find these on page 970. And oxalate is C2O4. So aqueous sodium oxalate and aqueous lead nitrate react to produce solid lead oxalate and aqueous sodium nitrate. And so now you have to have 2 sodiums and 2 nitrates for this to balance. So these problems continue, and on these you have the word problems and you have to come up with a skeleton. So try these before we go on, and I will just show you the answers here. It's important to keep track of the charge so that you get the skeleton equation correct. And so the sulfur is just a element. It's not a sulfate ion. When it says sulfide, remember the nomenclature from term 1, that's just sulfur. And since that's a +2 charge, you need 2 sodiums and 2 silvers to go with it. So if this was all balanced out, you'd have to put a 2 out in front of the silver nitrate. That's it for the front side. I will post the key, so if you want to see the answers to the back side, I'll post that as a PDF file.